tangent line is equal to 0, so when I come on down to the derivative, what are we going to do? We have a root. When the function has a horizontal tangent line, the derivative has to have a root. Okay? Fancy word for this point over here, we're going to call it a relative max. Okay, any other roots for the first derivative? Anna.
X equals 2.
Okay, at x equals 2, the derivative has a root because? You're absolutely right, but why?
Oh, because the tangent line is
Okay, the slope of the tangent line is equal to 0, and if I'm going to call this a relative max, then over here we're going to call this relative min. Now here's the thing, you may not have actually used the phrases relative max and relative min last year in pre-calculus. Right, you might have just said, it's the max, or it's the min. We are not going to say vertex because this isn't it's not quadratic. Vertex we reserve for quadratics. This is a relative max, and I want to focus on relative max because is this the absolute highest point on the graph? No, right, Michelle, there's higher? Where?
As you approach infinity.
Towards infinity, and there's an absolute min, right? Like somewhere out here. So these are relative max and relative mins. What I want to do is I want to use this information. I have tans equal to 0, tans equal to 0. They give me the roots. Yes, sir? Okay. So here's where we're going to go next. So we've got 2 points on the derivative. I want to get more points. Yes? Okay, don't use the word it though. You know better.
The function.
Okay, so the function is increasing over here, and this is where the colors are going to come in handy. Okay, if the function is increasing, then the derivative has to be
Positive.
right. Function increasing, derivative positive. Positive what is the excellent question to ask? Don't care about that right now. All I care about, function increasing, derivative positive. So if I have to be positive and I have to have a root over here, then I'm probably going to do something like that.
How do you know you have to go positive?
Because I'm increasing until I hit the relative max, and the derivative has to have a 0 there.
But how do you know unless like that?
Great question. These are all the right questions. For now, just kind of roll with it. Draw something that is positive, but getting closer to this root. Increasing anywhere else? Connor?
After the relative minimum.
After the relative minimum. Increasing again. Increasing over here means when I come down to the derivative, has to be positive. Okay? And I'm going to switch colors now because I like my colors. What about in between the relative max and the relative min?
Negative.
Alex?
Maybe negative function.
Okay, not the word it. What's the function doing between the relative max and the relative min? Decreasing. So when I go down to the derivative, the function has to be negative, maybe something like that. Okay, now I'm forcing this to look like a parabola. Because the original function was cubic, the derivative will be quadratic. What would it take? Joe?
So is the derivative, is the double derivative, one derivative?
Wait, how many double derivatives did you choose on here? 1. Okay, 1. So the original function is cubic, the first derivative is quadratic, the second derivative linear. Yes? You don't understand why I drew this little thing? Okay, I went fast there. This function is decreasing, so the derivative must be negative. But here's the thing. I have a root over here and a root over here, and I need to stay negative but hit both roots. Right, all we're saying is that if f is decreasing, f prime is below the x-axis. And the reason why I start with the relative max and the relative min is it tells me about my roots. And then that's a good guide. Okay? We're going to get some practice with this. How's the video coming up there? Okay. All right, good. All right, second one. What do we know about this one?
Absolute value.
Okay, we know the graph is, I was trying to do it with my elbows, and they can't touch. Okay, I always do it with palms. Those of you that can make your elbows touch, I hate you. Okay. Sorry, I'm just jealous. They used to be able to touch. Okay. Absolute value, what do we know? We know something different here. I heard it. I heard it. I heard an angry German word. There's a cuss point. The cuss point is over here. So what do we know about the derivative? What do you know, Melissa?
So it would be undefined at that point.
Over here you have a cusp point. You have a sharp point over here. So undefined over here. Now here's the problem. I don't know how to draw in undefined. All I know is that at x equals 0, yo, won't have anything. Yes?
So what you say on
Not necessarily. Not necessarily. And you guys will see in just a moment. All I want to focus on right now, cusp point in the function, first derivative is undefined there. Which means the first derivative cannot be continuous. There has to be some problem. Well, what could the problem be? Reasons why a function is not continuous include. Give me one.
limits.
Okay, limit issues, right? A jump discontinuity. What else could happen? Breaks. What else? Rebecca. Hole. What else? Vertical asymptote. Right. If you have a cusp point here, you're going to have some problem down here. Now, let's see. Function is decreasing over here. So the derivative?
Negative.
Decreasing, negative. Now we can even do better than negative here.
-1.
-1, right? This guy over here is really just the line y equals negative x. Because that is a line, a nice, easy to work with line, when I come down over here, the slope has to be -1. So I'm going to have slope is -1 all the way until that point right there. So this is the line y equals -1. I'm going to put a hole here because I know at 0, at a cusp point, it cannot be defined. Now I switch colors, I go to the other side. Hey, increasing, function increasing over here. This guy, function's increasing, first derivative is going to be specifically 1 because this is the line y equals x. And so this is going to be the line y equals 1. And I'm going to use the whole. The derivative is not continuous. In fact, even better, you know what exactly the parent function is for this? Creation of the parent function? Yes, that's what he's doing was for me. Nice job. Okay. So in this case, f is the absolute value of x, and f prime is the absolute value of x over x. That is not something I expect everybody to know. I was absolutely thrilled that Grace knew it, and Ivan, hello. LCL, I'm sorry, you guys have nothing to learn. Your grades are identical, but you learned nothing in life. How we doing? We're good? Ready for some calculator stuff? Okay. Say, oh, make me look smart. All right, you're already smart. So, yes, let's do this. Andy, can you turn the projector so it just shines right on here? Okay. So, I'm going to model this on the, where are my 84 people? My T84s? You first. Inspire people, it's different for you.
Anna, can you record this part?
Okay. Here's how it works for the 84 people. You're going to, okay, go to graph mode. We're going to type in the original function. The original function f of x was, I think, x cubed minus 3x squared plus 2. Is that the original?
Yes.
We're going to get your calculator to graph the derivative for you. And here's how it works. And the instructions are at the bottom if I go too fast or if I forget. Hit math. Scroll down. N deriv. Any guess what that is? It's a derivative. Right. The n is it's a numerical derivative. You hit n deriv. What do we want to take the derivative of? y1. To do that, bars, y1. Now, you have to tell it that it's a function with respect to x. So you type in comma x. Then you tell it to take a derivative with respect to x. Right now that sounds like gobbledygook. Just have faith. That's what you type in. Nderiv y1 comma x, hit enter. Here comes y1. And slowly, oh so slowly, because your calculator's doing a lot of heavy lifting here, that's the graph of the first derivative. Anna.
Mine is weird.
Okay, I'm going to add, oh, okay, if you have the new software, then yours works like an Inspire does. Okay? TI-84 people, are we okay? Try it with the second function. Make sure I'm not lying to you about the graph, and then try the practice problems. Inspire people, let me get you next. All right, on the
absolute value on the
absolute value, you hit math and go over to number, and then it says ABS in parentheses. Math number. Inspire people.
There's a glare.
There's a glare.
So you just turn it. And you can tell the brightness of it.
That sounds so technical.
No, on the computer. I mean, on the calculator.
On the calculator? Okay, well, I don't know what to do. Okay. So we're gonna, yeah, Andy, do what you gotta do to me. Be gentle. All right. I want to get a sheet of paper. Okay, I've got one. There, that's better?
Alright, so.
Oh, so I need like a little umbrella. Okay, you just do that. This is so weird for me. All right, let's do this quickly before, Andy's arm falls off. Okay, type in same function, x cubed. I'm sorry, you try speaking in 2 different languages at the same time. Let's see how well that goes. X cubed minus 3x squared plus 2. There's the graph. Now, Inspire people, you're going to type in F2. Your calculator, and this looks a lot like the 84. Hit the button next to the Bible key. And that screen pops up. Okay? And this screen has all these fancy commands in there. The one that you want is this guy over here. The D over D box. That is one of the derivative notations. Sorry, Andy. Okay. So now you're going to... Oh, no. Wrong one. Don't worry about the D2 thing. Okay. Hit the little thing next to the Bible. Hit the first one. Now I want the derivative. We're going to do derivative with respect to x. Then we do vars f1 x. Double parentheses, because I want the derivative of f1, and you have to put in the with respect to x. Hit enter. Hey, there's the first derivative. Ivan.
On mine it has that, but it says at x equals.
Yeah.
Hat x equals the slash bar. Right, it means at x equals a particular point. I'm going to look at yours in particular, okay?
So what point?
You're not. I don't want you to put in a point. So I'm going to figure out what's going on with yours. We'll fix that. 84 people, are we okay? We're moving on to the practice problems. Inspire people, we're going to have some conversation. Andy, you've been a great umbrella. You can have a seat.
I don't know how to print the F1. Would that be a Y1?
So, let's see. You're going to take the derivative. We're going to try vars, y vars, y1, x equals x. There we go. Okay. For the people that are having the issue, your calculator pulls up d by dx or d by d box, and then the parentheses, and then the box, and then this, and the box. Okay. The 84 people have to say, you've taken a derivative with respect to x, name your function, which is like your f1 or your y1, at x equals x. It worked on Anna's 84. It should work on everybody else's Inspire. We're good? All right, move on to the practice problems. I want to see what you can do without your calculator first. This is like a sketching activity. Then confirm the results with the calculator. Let's keep recording till the end of the period. Is that okay? I mean, if you want to shut this part off, that's fine.
Okay. Connor, shut it off. Spreads out, right?